So in this section, we're going to take the information that we've already learned about writing the equations of lines, and we're now going to be writing the equations of parallel lines and perpendicular lines. All right, and what we need to understand in terms of vocabulary is what is a perpendicular line, what is a converse, and what is a conditional statement. So first, let's talk about the relationships of lines and perpendicular lines. So when we talk about parallel lines, if two non-vertical lines in the same plane have the same slope, this is the key thing. Parallel lines have the same slope. Okay? Right? These are what we would call conditional statements. Right? Both of these are conditional statements. If, then. That's what gives us the sense that this is a conditional statement. If this is true, then that is true. If this is true, then that is true. Okay, so if two non-vertical lines in the same plane have the same slope, they are parallel. And if they are parallel, then they have the same slope. Okay? They also have the same slope if they're the same line, but that's a different situation. Right? So if I want to write the equation of a line that passes through a specific point and is parallel to another line, what that is we're talking about lines that have the same slope but different y-intercepts. So probably the first thing I want to do is I want to find the slope, and what I'm going to do is, this isn't in standard form, but it's kind of close to standard form. What I want to do is put it into slope-intercept form because I just want the slope. Right? So if I divide everything by 3, y is equal to 1/3 x minus 4. So I divided everything by 3, and I can see then that I can see that the slope is 1/3. Now that I have the slope and a point, then I can use point slope to write the equation of my new line. So we're still in this family of writing the equations of lines. What's changed is, how did I get the slope? Well, I got the slope by pulling it from another line that was parallel to my line. All right, so if I have y minus 2 is equal to 1/3 times x minus 18, I'll have y minus 2 is equal to 1/3 x minus 6. And if I add 2 to either side, y is equal to 1/3 x minus 4. Oh, well, look at that. They're the same line. Okay, so these are, theoretically, they're parallel lines, but they're really the same line. Right? For it to be a different parallel line, it would have to also be, it would have to have a different y-intercept. If we want to double check this, if I plug the x and y's into my first equation, this one here, 3 times 2 equals 18 minus 12, 6 is equal to 6. Oh, well, this is a point on that line. Of course it is. They are actually the same line. So I wouldn't say they're parallel. I would simply say they're the same line. Okay, parallel lines have the same slope but a different y-intercept. Okay, back to the concept of conditional statements. If, then. If, then. And what are we talking about? If these guys have slopes that are negative reciprocals, the lines are perpendicular. Right? If the lines are perpendicular, slopes are negative reciprocals. Okay? And the way that would look like is slope 1 is the negative reciprocal of slope 2. Okay, that's how you would calculate it out. So now we want to determine, are my slopes parallel or are they perpendicular? Well, let's take a look at our slopes. All right, so in this case, I have 3 different slopes. Is line A parallel to line B? right? No. So A to B they are not parallel. Are they perpendicular? Sorry, that's really not the way I should have written it. That's really not equal to. They are not parallel. Okay, but their slopes are negative reciprocals, so they are perpendicular. Okay, if I looked at A to C, 4 and negative 4, they're opposites. They're not the same, and they're not negative reciprocals. So they aren't parallel and they aren't perpendicular. And if we look at B to C, negative 1/4, no, they're not the same, so they're definitely not parallel. And they're not negative reciprocals, so they're not perpendicular. Okay, the Arizona state flag is shown in this coordinate plane. There you go, lines A and B, right? So I have line A here and I have line B here. They appear to be perpendicular, but are they? So what we're going to want to do again is we're going to want to compare the slopes. And in my opinion, the easiest way to do that is to put them into slope-intercept form. Slope-intercept form. So to do that, I would divide by 12. So y would equal to negative 7/12 x plus 42 divided by 12. So if I want to simplify that, I'll have negative y is equal to negative 7/12 x plus 42 divided by 12 would be 21. Well, I could take a 3 out of each of them. 3, so that would be 14 over 4. Sorry, that means I could do even more. 14 over 4, so it would be 7 over 2, right? So I factor a 6 out of each, so I get 7/2. And if we look at this other equation, B, if I divide both sides by 11, y equals 16 divided by 11, x minus 52 divided by 11. If we look at these slopes, are they negative reciprocals? No. No, this would have to be 12/7. Right? So this is not, they're not even particularly close to being perpendicular. Right? For this to be the negative reciprocal of that, it would have to be inverted, and then the sign would have to be changed. So it would have to be 12/7. So the lines are not perpendicular. Okay, one more example. Write the equation of a line that passes through the given point and is perpendicular to the given line. Okay, so I know that my slope for my first equation is 5. So I know that 5 will be equal to negative 1 over m2 if I multiply both sides by m2 and divide both sides by 5, I'll have negative 1/5. Equally, I could have just said invert this, 5 becomes 1 over 5, and change the sign, make it negative. So I have the slope and I have a point. We're going to go ahead and use point slope again. Y minus 1 equals negative 1/5 times x minus 5. So I'll have y minus 1 is equal to negative 1/5 x plus 1. And if we add 1 to either side, y is equal to negative 1/5 x plus 2. Okay, this line is perpendicular to that line. They have slopes that are negative reciprocals, and this line will also pass through that.